video for WJC M3 pure area between two curves. This is M2.3.7B1. The area between two curves is fairly obvious to deal with. It's worth remembering, of course, that the area between a curve and an axis is given by the integral between some limits of whatever your function is with respect to the axis in which you're interested in integrating. So from my diagram you can see that I've got a lilac area which is denoting the area underneath my curve, and between the x-axis between x equals 2 and x equals 1. My orange area is between the curve and the y-axis between y equals 2 and y equals 5. So it's possible to find different axes depending on what you're dealing with. So clearly my lilac area is given by the integral between 2 and 1 of x squared plus 1, because that's my function in x with respect to x, and that gives me that particular area that I'm looking for. The orange area requires a little bit more work. Obviously my function is, in this particular case, it would be the integral between the limits of x with respect to y. But my curve is y equals x squared plus 1, so therefore I've got to do y minus 1 is equal to x squared, therefore x is the positive root of y minus 1. And so therefore my limits are y equals 5, y equals 2. So the integral between 5 and 2 of the root of y minus 1 with respect to y will give me the orange area. It's a more difficult integral, but not impossible. If you think back to your reverse chain rule on 7a4, it's possible to do. And of course the other way of doing it would be to treat the orange area and the lilac area, if you like, as two rectangles and subtract, in order to find the orange bit, you could subtract the area, which is reasonably easy to find, the integral between 2 and 1 of x squared plus 1 with respect to x, from the entire area of those two rectangles, but that's neither here nor there. So if we're looking at the area between two curves, you notice I've got here a concave curve and a convex curve, and my curves are clearly y equals minus x squared plus 4x plus 1 and y equals x squared plus 1. And we want to find that area between the two. I've not shaded it in this case because it would just clutter up the diagram. So you can probably work out the points of intersection from my graph. Reasonably obvious, but it's good technique, especially under exam conditions, to show the algebraic approach. So therefore I've got y equals x squared plus 1, y equals minus x squared plus 4x plus 1, and by the associative law of mathematics, seeing as they're both equal to y, I can say that x squared plus 1 is equal to minus x squared plus 4x plus 1. And fairly obvious that's an equation all in x, which makes life easy. Clearly one way of solving simultaneous equations here, isn't it? So therefore I get 2x squared minus 4x is equal to 0. Take out your common factor. Lots of people put 2x squared equals 4x and then cancel an x, but of course you lose a factor there. Take out a common factor. Cancellation is not something you should do really on a general basis in mathematics. So 2x bracket x minus 2 equals 0, and we know that because of the nature of 0, either 2x is equal to 0, which implies that x equals 0, or x minus 2 equals 0, which gives me that x equals 2. So therefore I get my two results, x equals 0 and x equals 2. So those are my limits in that particular case. Now the area I want is the area underneath the burgundy curve, red curve, minus the area underneath the gold curve, because I'm looking in terms of the x-axis, seeing as my functions are in terms of x. I could do it in terms of y if I wanted to, but I don't really fancy it. So I'd have to use two integrals. my first integral, the integral between 2 and 0, which are my limits of minus x squared plus 4x plus 1 with respect to x, gives me the entire area contained between the lines x equals 0 and x equals 2 and that red curve, minus the integral between 2 and 0 of x squared plus 1 with respect to x. That's the area underneath the gold curve between and the lines x equals 0, x equals 2. So I've got two integrations to do. Fairly straightforward integrations, not too much of a difficulty. For some reason, PowerPoint won't allow me to put limits on square brackets, so I've scribbled them in, but for some reason one of them isn't behaving itself. So my integration of minus x squared plus 4x plus 1 will give me minus x to the 3 over 3 plus 2x squared plus x between the limits 2 and 0. And my integration of x squared plus 1 will give me x cubed over 3 plus x between 2 and 0. Now I've got my limits in. So putting my limits in, and I've said before, it's a good idea. Now fairly obviously in both these functions, both these integrands, have all got x's in. Therefore if I put 0 in instead of x, then I will get a 0, but it's a good technique to show that you know it's minus 0 because you're clearly showing putting the limits in. So putting in these in, minus 8 over 3 plus 8 plus 2 minus 0 minus 8 over 3 plus 2 minus 0, which obviously the 2's disappear. I've got minus 8 over 3 plus 8 minus 8 over 3, which is minus 16 over 3 plus 8. And 8, of course, is 24 over 3, so therefore 24 over 3 minus 16 over 3 is 8 over 3 square units. And you don't have to put units squared in. I just have done. There is an alternative way of doing it, and this is something I quite like. So from my previous example, exactly the same question, so hopefully I'll get exactly the same answer. My integral between 2 and 0 of minus x squared plus 4x plus 1 with respect to x minus the integral between 2 and 0 of x squared plus 1 dx. It's worth remembering that the operation integration, and it is a mathematical operation, distributes over addition and subtraction. So therefore we've always used the fact that the integral of a to the x plus b is the integral of a integral x plus integral b, so we distribute that quite happily, so we can spread it over just to make our life easier. So therefore I can actually rewrite this as the integral between 2 and 0 of minus x squared plus 4x plus 1 minus x squared plus 1, all with respect to x. So without any real problem, and that becomes then the integral of between 2 and 0, and of course I get minus 2x squared plus 4x with respect to x because of the negative sign distributing through the second bracket, and then this becomes a nice easy integration. Integral of minus 2x squared is minus 2x to the 3 over 3, or minus 2/3 x cubed if you prefer, and the integral of 4x is 2x squared. There's a plus sign between the two, but my limits are 2 and 0, and I will get, when I put x equals 2 in there, I will get minus 2 times 2 cubed, which is 8, times minus 2, which is minus 16 over 3 plus 8, minus 0, again I've got this minus 0 in there just to show that I am actually putting my lower limit in there, and I'm back to the same situation as I had before. 8 of course is 24 over 3, and minus 16 over 3 plus 24 over 3 is positive 8 over 3 units squared.